Okay, so on this, now this thing that's called Gauss-Jordan elimination, you don't have to know, because you're going to do this on the calculator. So what I'm going to do is kind of bypass, in this class, the procedure of how you do this by hand. I'm just sort of going to talk through it, and then we're going to go over to the calculator like that. So you don't need to really worry about this information here. Let's go to page 5. And what's going on this problem is this would be the way you would do this by hand. This is, if you want to read over this, you can, but I'm not going to show you how to do the row operations to put this in a reduced row echelon form. So what I want to show you is, this is what I want you to pay attention to on this page, is if you did this by hand, excuse me, by hand, that's what you would get, okay? And we talked about that last time. When you have reduced row echelon form, you have a diagonal of 1s. So what this really means is the first row means x1 is 2, x2 is 0, x3 is -1. So that means this is the answer to the problem, is 2, 0, -1. Now what you're going to be required to learn how to do is how to do this on a calculator instead of having to do that by hand. Doing it by hand's not hard, but it's easy to make mistakes on that, so I'm not going to worry too much about that. So we're going to work a little bit more with the calculator today and look at a few situations we didn't have time to do them, okay? All right, so it's helpful if you brought your calculator today. So I'm going to show you again a little bit more of how I want you to do these on the calculator. So if you'll go to the next page, let's do this together on your calculator. When you're like doing a test or something, what I want you to do is just, the first thing I want you to do is write down the augmented matrix like we learned last time. So this first row would just be all of the numbers. You have 1, 1, 1, then you have the bar, and then you have the 3 like that. So you have a column for x1, x2, and x3. The second row is the same way. You just go 2, 3, 7, 0. And then the last row is going to be 1, 3, -2, 1 like that. Okay, now that's what I want you to do, is write that down. Now we're going to go to the calculator, and then we're going to write down what the calculator gives us. So go ahead and get your calculator out and try to run through this. I think last class, those of you that had a calculator seemed like you were doing okay. Just do exactly what this tells you to do. All right, now I'm going to run through it. Just go ahead and start putting everything in. So the first thing is you go to your matrix. You go second x to the -1 to open up your matrix. We're going to put this in matrix A. It doesn't matter. You can put it in any matrix you want to. So press enter. Okay. Whoops, you got to do edit. I forgot about the edit thing. So you have to do that. Go to edit. Okay. Just press enter. Just follow the steps. Okay. And then what you have to do here is you have to do the right size. So the key thing is you have to know what the size is. Okay. Remember we learned the size. It's how many rows, how many columns. How many rows does this have? 3. How many columns? 4. So it's a 3 by 4 matrix. So you want to put this in like this. Just put in the 3 and then do the 4. You can just press enter right each time you do that. So now what it does is it's just got it sized for you. Now start putting the numbers in. Okay, so just go ahead and start doing that. Okay, and this will be a real simple thing to do. So on this, as long as you know how to use your calculator, you're not going to go wrong. So the next thing is 2, 3, 7. Gotta be careful. 2, 3. Press enter after everything. And I think I got one of those wrong. So that's 3, 7, and then 0. And then the last row, what I get is 1, 3, -2, and 1. And just let me know if you don't see how everything's being put in. So that's step 1 really, is just get your matrix in. Okay, is everybody with me there okay? Okay. Now what you want to do is you want to have the calculator put this in reduced row echelon form. So you start over again. One thing that you want to do is you want to quit. So if you've got that on your calculator, you have this quit button right here above mode. That takes you back to a clear screen. So you got to go second mode to get to a clear screen. Okay. Then just do the steps in this second box right here. Just go second, x to the -1. Okay, then go to math. Step 2 on this would be math. and then keep going down until you find the one that has 2 R's in it. Make sure you do the one with the 2 R's. Press enter. Okay. Now you got to go back to your matrix again. So you got to go back to step 5, second x to the negative 1. And then you got to highlight the A and just press enter. So ultimately what you want on your calculator is matrix A in and then that on your calculator. Now when you press enter, it'll give you the reduced row echelon form. So if we've done that right, are you guys getting a bunch of decimals on that like I am? Okay, that'll happen sometimes. Okay, it doesn't have to be whole numbers, so we're just going to round this off. So, and I do want you to write this. We'd have 1, 0, 0, and let's just call that a 5.9. The next one is 0, 1, 0, negative 2.2, all round, and then 0, 0, 1, negative 0. Let's just round that to 0.8. Okay, so if you get everything put in your calculator, that gives you the solution of that system of equations. So what you'd want to do is write the answer. The answer would be x1 is 5.9. x2 is the middle row. That would be negative 2.2. And then x3 is the last row. That's negative 0.8. You'll appreciate that I'm letting you do this on the calculator. It's not that it's hard to do it by hand, but it is super easy to make mistakes on it with arithmetic. And in practice, you know, that's what you're going to do in the modern world on matrices is put these together, and then you want to put these in your calculator. Okay, is that working? Tell me if that's going okay for everybody. Okay, all right. I want you to go ahead and do the next one yourself. All you have to do is just type over what you already had. Okay, so just you want to write down your augmented matrix, and then you want to write down what comes out on your calculator, and then just we'll kind of compare answers and see if we're doing this right then. Just follow the steps that I have. You should just have to type over the matrix we did on the previous problem. Make sure you get your negatives and everything in there right. So again, you want to get to the point like I have up on the screen. I've typed over what's in A, and then RREFA in a clear screen. Have we got anything yet? What did we get? We got decimals again or something? Whole numbers. Bunch of whole numbers. Okay. So tell me if you got this. Does that look what you got? Okay. So again, like on a test, see, all I want you to do is just on your paper, I want you to just write down the original matrix. Oops. And then the result that comes out on the calculator. You're going to do this 100% on your calculator. So I just want to see that you have this, and then write down the answer. Okay, so the answer looks like is 1, 0, negative 7, 0, and 0, 1, negative 5, 0, and then 0, 0, 1 like that. Okay, now something different happens on this problem. So we haven't talked about that yet. But mostly I want to see that you've got everything in your calculator okay. Now here's what this means. It means this. So basically that first row right here, that first row, and you want to write this down. What that first row means is 1x1 plus 0x2 minus 7x3 equals 0. That's what the meaning of that equation is in those numbers. The second row means this. Okay, that's going to be 0x1 plus 1x2 minus 5x3 is equal to 0. That's what that means. Now the last one's kind of weird. What the last row means is it means 0x1 plus 0x2 plus 0x3 equals 1. Now remember, what we've learned so far is when you solve a system of equations, there's two possibilities. Either you get a solution or you don't. Now I want you to look at this last row right here. You know what this really means? It really means 0 plus 0 plus 0 is equal to 1. Is that true? No. So that's a no solution one. Remember, it's got to look like the diagonal has to be 1, 1, 1 like that in order for it to give a solution. So if you look at the previous problem we did, we got a solution. So basically, anytime you get something like that, that just means 0 is 1. So that is a no solution. Yes?
But if that 1 was a 0 and it was just all zeros, it would be...
Okay, then it would be infinite solutions, which we'll learn today how that goes. So basically what you want to make sure that you know is if you have like all zeros and then a number, then it's nothing. But if it's all zeros, it's going to be everything works. Okay, and we'll kind of get to that. Okay, is there any question about what I'm doing there? Does that look okay? Calculator working okay? Yeah, okay, all right. Okay, so let's see. Let's go to the next thing here. And again, just write down the original matrix and what came out on the calculator. Your job is to interpretate the meaning of what comes out on the calculator. Okay, so I'm going to talk about infinite solutions. So what I want to go ahead and do on this, I want you to go ahead and do this one in your calculator. So I want to go ahead and have you do that. Just type over the same problem that you did. Okay, and just put these numbers in on that. So you can just type over everything and then do the reduced row echelon form. Let's go to edit and then type over everything because this is the same size matrix that we had. Just run through that and see what we get. Always make sure you get the numbers in. Okay, and again, once you got your matrix in, just quit, get to a clear screen. So I'll go second mode, quit, then go back to the matrix. This time do math. Go down until you find the reduced row echelon form, which is kind of down towards the bottom. And then just put that in. Let's see what we get then. Come on, stop. There we go. Okay, put in the matrix A, and then we'll kind of compare and see if you get what I get then. Okay, does that look like what's coming out? Are you getting a row of zeros? That's the key thing. Okay, that's what should happen. Now, the page that I printed out for you, I took out of the book. This shows how you would do it by hand. Again, you don't have to know the row operation method of doing this by hand. So what would happen on this then is you should end up getting this matrix here. So this is what should have come out on your calculator is that. Okay. Now what I'm going to show you next is something that's new. So anytime you get a row of zeros, this is important to write down, that means that you have infinite solutions. Okay, so anytime that happens on your calculator, you get infinite solutions, but I don't want you to write the answer that way. We're going to learn how to do what we call a parameter. Okay, so let me show you how this goes then. Is everybody okay with the calculator so far? Okay, that's important. Okay, next thing I want you to do is write down what each row means. That first row, 1, 0, 1, negative 3, what that means is 1x1 plus, and you don't have to put the 0x2 there. You can just put 1x3 equals negative 3. You just leave a blank where there's a 0. The second row is 1x2 minus 2x3 is equal to 4. Now, that's all you need to write down. When you have a row of zeros, then you have to do what's called parameterizing. So you'll catch on to this. It may take a little time to understand what's going on. So what you're going to do on this then is we're going to write this as a parameter. So what we typically do is we've got x1, x3, and then we got x2 like this. So what we're going to do is we're just going to do this. We're going to let x3, you typically are going to use x3 and just give it t. I'm going to do what the textbook does. You just give it an arbitrary letter. Okay, so it goes like this. Then what we're going to do is we're going to do this. Take the first row. That's going to say x1 plus t equals -3. Okay, so again, what I'm doing is everywhere I see an x3, I want to replace those x3s with t. Right? You want to solve this for t, so that just means slide the x1 over. So you get t1 equals -x1 minus 3. So far, you want to have that, and you want to have that. You just call x3 t. T is the letter I'm going to have you do most of the time. Okay? Second thing we do is take the second equation, do the same thing. This is just going to say x2 minus 2t equals 4, and then solve that equation for x2. Okay, so you can do that in your head. You just move the 2t to the other side, so you get x2 equals 2t plus 4. Okay, and I'll pause there and kind of explain what I'm doing on that. So basically what you do is you write your answer like this. You just say hold on, I think I wrote this one wrong right there. This one right here I wrote wrong. That should say x1 equals -3 minus t. You're solving for x1. Okay, you're just finding what x1 is, what x2 and x3. So you write your answer like this. You say x1 is -3 minus t. You say x2 is 2t plus 4. Then you say x3 is t. That's how you write your answer. Anytime that you have a row of zeros, it means you have infinite solutions, but the solutions work this way. So like if you just pick t to be a number, like if t was 0, then that would be 0. That would be -3 minus 0. That would be 2 times 0 plus 4. It gives you what all of the solutions look like. So again, just go through this. We'll do this several times today. If you see a row of zeros, write down the other two equations, and you'll usually have the same variable twice. That's the one you want to set equal to t. And then I just did x1 plus t equals -3, solve. Then I do x2 minus 2t equals 4 and solve. Does that make sense? Tell me. A lot of times students don't understand that the first time they do it. X3 is t. You just give it a letter, and t is what we're always going to do. Okay? All right, now we'll understand this, think a little bit better when we do an application on here today. So that's the idea of how you handle it if it's got a row of zeros. Yeah.
So let's say in that situation, you had a number for x2, you would put it in like x1 plus whatever x2 plus t equals -3, and then you'd have to do that.
Yeah. The idea is usually what will happen is something turns out to be the same, so that becomes your parameter, and then the other two things, x1 and x2, are named in terms of t. Right. You'll see there are times when you have to use two parameters. I don't know if we'll see that or not, so that's the idea. The other thing that you want to write on your paper is this. You can also write the answer like this, and you need to write this down. You just say -3 minus t, comma, 2t plus 4, comma, t. Okay, remember what you are used to doing when we solve a system of equations is writing a point where they intersect. Now this problem, you'll never be able to visualize what's going on. You actually have 3 lines in 3 dimensions, so that's where they intersect in 3 dimensions. I'm not going to worry about that so much in this class, but that's technically what it means, because that's a point of intersection. Now I'm going to have you write one more thing, okay? Let's just let t be 0, and I'll give you one solution, just so that you get the idea. So if you replace all of these t's with 0, this would give you one specific solution. This would be -3 minus 0, comma, 2 times 0 plus 4, comma, 0. And if you work out the details, that would be -3, 4, 0. So that is one solution. But what you can do is t can be anything. So you get an infinite number of solutions, but they all are defined by those three equations.
So you would have to do that whole thing?
No, you don't have to do that.
No, I'm just saying, you have to do it 3 times for that.
Yeah, the thing on that is t can be anything.
Right.
And if t was 1, then you would get another set of answers. If t was 2, you'd get another, and so forth.
Oh, okay.
That's the idea. So I just said let's let t 0
right.
to show you that that would be one specific solution of that system. There's an infinite number. What you're typically going to do is just write it one of those 2 ways, like that. That's the idea. Okay. Any question on that? Okay. Let's see. Let's go to this next one. I'm going to do finish this section up with just this application. And this is going to be similar to what we're going to end up doing in the next chapter, in chapter 5. We're going to learn how to do something called linear programming. So this is kind of a typical situation that you have. First of all, in this problem, it says that you're making 3 different types of boats. The types of boats you're making are a 1-person, a 2-person, and a 4-person. Okay, when you put this together, when the company puts this together, there's 3 departments. There's the department that does the cutting of the materials, and this is the amount of time for each boat. You would expect it to take more time, maybe for the 4-person boat. Then there's an assembly row that tells you the amount of time it takes that worker to do one of those boats. Then there's the packaging, putting that all together. So we're going to have a system of equations on this, and we're going to solve on a matrix. So what we want to do to start with is, this is what everything means in this problem. When you read the question, it says, how many boats? And that right there tells you what your unknowns are. So you want to write down x1 is going to be the number of 1-person boats. Okay, it's always good to write down what these variables mean. Okay, x2, I like to use x1, x2, x3. You could do x, y, z also if you wanted to. That's going to be the number of 2-person boats that are made. And then x3 is going to be the number of 4-person boats. And what we're going to do is we're going to have 3 equations and 3 unknowns on this. Okay, and it kind of goes like this. All right, so the first equation goes like this. If you look at this first row of numbers, that gives you an equation right there. That first row is just going to give you 0.5 times x1. Okay, every time you have a boat, it's going to take half an hour to do the cutting on that. Second number is 1, so that will be plus 1 x2. Every time you have a boat, it takes an hour to cut the materials for a 2-person boat. And then finally, you'll have 1.5 x3. Now, you have to read the rest of the problem. The rest of the problem says that for cutting, you have a maximum of 380 labor hours available, so that's going to be equal to 380. So that's telling you these are the amount of times for each boat and each piece that you're on the cutting. That's the number of hours you have. Now, once you catch on to this, the rest of it is exactly the same. So the second equation will be that middle line, which is just going to be 0.6 x1 plus 0.9 x2 plus 1.2 x3. And if you read the problem, it says that the assembly is 330. That's how many hours you have available of labor on that then. And then the rest of it, once you catch on how to get the first equation, they're all the same. The next one is going to be 0.2 x1 plus 0.3 x2 plus 0.5 x3, and then that's equal to 120 labor hours like that. So that is the system of equations that we solve, and what that would do is, given these conditions and given the labor hours of 380 for cutting, 330 for assembly, 120 for packaging, then we can find if there's an optimum solution to that. Okay, does that make sense, what I did so far? Okay. Now, what I want you to do is, we're going to do this on a calculator. All right, so what we're going to do is just solve this system on the calculator. So really all I want you to do on your paper is just write down the augmented matrix and go ahead and put that in your calculator. So I'm just going to do the columns. It's the same size. It's still a 3 by 4 matrix. and can run through all the way to the reduced row echelon form in that. But you do want to write on your notes what that what the augmented matrix is. Okay, and then we'll just see, as long as you get your numbers in and are catching on how to do this on the calculator, then you should be fine. So I just type over what I had because it's still a 3x4 matrix. Let's just get everything in then. And you might get, and I think you'll probably get whole numbers on this one. I took this out of the book, so it's probably got nice numbers on it. It should, because it's the number of boats. So it would make sense that it would have that. Okay, all right. Are you guys getting whole numbers? You guys can do the type on your calculator faster than I can on this emulator up here. Okay, so I'm going to do the reduced row echelon form like we've been doing. Oh, that's not what I wanted to do. Okay, so you can tell me if you get this. Does that look like what you're getting?
Yeah.
Okay, good. Okay, so this gives you 1, 0, 0, 20, 0, 1, 0, 2, 20, and then 0, 0, 1, 100. So now you guys got to interpret what the meaning of this answer is. Okay, so what this means is this is x1. That first equation, that's just telling you x1 is equal to 20. The second row is telling you x2 is equal to 220. Then the third row is saying x3 is equal to 100. Okay, that's what reduced row echelon form is always going to have, a diagonal of ones this way. Everything else is zeros. If it was 0, 0, 0, 100, then it would be no solution. If it was 0, 0, 0, 0, then it would be infinite solutions. So that's one solution.
So, if there is a 0, 0, 0, 0, then you're going to ask us to give a solution.
Yeah, then you got to do that. You got to do that parameter, and then you got to maybe give a specific solution. Yeah, and we'll get to that. Okay. So here's what this means. Now you want to write down what this means. So x1 was the number of one-person boats. So your answer needs to be written this way. You say 21 person boats. Okay. 220 is the two-person boat. So you say 220 of the two-person boats. And then finally you say 100 of the four-person boats. So, I mean, you need to know what we just did. That's what we did in that problem, is it turns out that given the labor hours that we have, that's the optimum solution. Okay, that's what you'd find. And we're going to work with that a little bit more in the next chapter, but that's the idea. That's just kind of one illustration of what you can do matrix for in order to solve just one application like that. Okay, does that look okay? I think everybody seems like you're getting the calculator part down okay. So once you get that, you don't have to worry about how to do this by hand. That's the idea. Any questions on what I just did?
So like what's B and C to the question?
What's that?
What's B and C?
Oh, I got to do B also. Okay. Yeah, I was going to do B, but I'm not going to do C because it's pretty similar. Okay. All right. Yeah. So that's the answer on that. So let's go ahead and let's do B then on this. All right. So what's going to happen on B? I'm mainly just going to set this up and then we'll do this on the calculator. But C, I'm not going to do. I didn't intend to do that one. Okay, so B says, how is the production in Part A affected if the packaging is no longer used? Okay, so the packaging, we're just going to wipe out that row right there. That's what it says. Okay, Part C would say you wipe off the column of four-person boats. Okay, so what we're going to do is we're just going to go ahead immediately on Part B, and we're just going to write down the matrix. That first row is going to be 0.5, 1.0, 1.5, and that's equal to the 380. So that's identical this. The second row is identical to the last problem. You would have 0.6, 0.9, 1.2, and then 330. Now that's the matrix you're going to do because we're just wiping out that row. Okay? Now, we're going to put that in our calculator. The size is different. What size matrix is that? 2 by 4. Okay? So it's 2 rows by 4 columns. So you want to go to your calculator and you want to change this now. Okay, so we're going to go ahead and put this in. You can just type over, or you can go to matrix B. I'm going to go to matrix B since I've already got A set up. So I'm going to just choose to put this in matrix B. You can do that too if you want to. So again, now what we have is 2 rows by 4 columns. And it'll size it. You're going to know if you did that right. We got 0.1, 1, 1.5, 380. And then 0.6, 0.9, 1.2, 330. Okay, like that. So if you get those numbers in, then you should just be able to do this in reduced row echelon form. And then we'll interpret what that is. So I go quit to get to a clear screen. Then I go back to the matrix menu. I go to math, and then I do the reduced row echelon form. But this time what I'm going to do is put matrix B in. Okay, whatever you put it in. So I'm going to go to matrix, highlight the B, and ultimately after you do all that, that's what your ultimate goal always is. Okay, so let's see what comes out if you do this then. Okay, well I got, is that what we're getting?
Yeah, you put it in matrix A.
Oh, I did the wrong thing.
Yeah. So we could have put it in matrix
No,
A?
you got to put it in where you put it in. If you put yours in A, I don't think mine saved that right.
Yeah,
or
put
something.
it in A.
Did I put it in A?
It's a 2 by 4 now.
Yeah, I did. Okay, there we go. Is that better? Okay, all right. That's what we should get. Yeah, I put it in A. I thought I put it in B, but I didn't. Okay, so what we have then is after you put that in, whoops, that's not what I wanted to do. Okay, let's just write down what the result is. So the result of that would be the matrix 1, 0, negative 1, negative 80, and then 0, 1, 2, 420 like that. Now that's not really a reduced row echelon form. So what you're going to do is you're going to get an equation on this. This first row, you want to write down what that means. That means x1 minus x3 is equal to negative 80. Okay? And then the second row is just going to be x2 plus 2x3 is equal to 420. Okay? So what you're going to have to do on this one is we also do a parameter on this because we don't get a specific solution. So we're going to do the parameter on this one as well. Notice that those are the same. Okay? And you do that if there's all zeros, but if you have a matrix like this where it's 2 by 4, where you don't have a diagonal of 1s, you also want to do that parameter. Okay, so here's what we do. Just let x3 equal to t, like that. Okay, and then what will happen on this is the first equation is going to say x1 minus t equals negative 80. Just replace x3 with t. So solve that for x1, you get x1 equals 80 or negative 80 plus t. And then x2, you would have x2 plus 2t equals 420. Okay, so again, you just take that and solve that for x2. So if you move that over, you would get x2 is equal to 420 minus 2t. So you would write this solution. Then I'll show you a little bit of what some of the specific solutions are. So you would write this just kind of as a point. x1 is, I'm going to write that as t minus 80. x2 is the number of two-person boats. That's 420 minus 2t. And then x3 is t. So that's how you would write that solution. And what you can do on this is you can vary this. Okay, and I'm just going to give you one example of a solution on this. And you got to think about this a little bit. Now remember, the answer to these are numbers of boats. So if I do a t there and get a negative number of boats, that makes no sense. So what if I let t be 80? Then that would be 80 minus 80. That'd be 0. That's logical to have no boats, right? Okay. If I did 80 in there, I would get an answer. If I did 81, I would get another answer, and so forth. So what I'm going to do is I'm going to show you how to get maybe 2 specific answers on this problem. So let's start this way. Let's just say t is 80, and then plug in. Everywhere you see a t in that answer, just plug in. So you would have 80 minus 80. Yes?
I have a question. In the t minus 80, 420 minus 2t, why is there a t at the end if there's not a third?
Say that again, I'm sorry.
Why is there a t at the end in those parentheses? I guess.
Because that's what x3 is.
So you have to just put
Yeah, that's where we started, is the one that you had an x3 show up in both equations. So that's your parameter. Whatever that parameter is just t. So I'm letting that be x3 be t, and then I'm plugging in everywhere I see an x3, I'm plugging in a t.
Right.
So I have x1 minus t equals negative 80, x2 plus 2t is 420, and then solve.
Yeah, but why do you put it in parentheses? Like, why do you have to include it there? Just because
Oh, you
it
don't
is-
have to put it in parentheses. You can write your answer.
So it could be t.
You can write
minus
it this
80.
way if you prefer. You can say x1 is this, x2 is this, x3 is that. So you can either write your equations, your 3 equations. I like to just put it in a point. That's x1, that's x2, that's x3. I like that. Okay, now let's just work this out then. So if I do this and plug this in, I'm going to have 80 minus 80, 420 minus 2 times 80, and then t, I just let that be 80. Okay, so that would end up giving 0. You can do this on the calculator. So if you do 420 minus 2 times 80, you can do that if you want to. So I'm going to go 420, 2 times 80 is 160. So that would end up giving 260 and then 80 like that. So what that means is this. Let me see if you guys understand that. What's the meaning of the 0? What does that represent? One person votes. So none of those, 260 of the 2-person votes, and then 80 of the 3-person. That's a possible solution that would optimize that. Okay, so you have many solutions on this. Okay, let's just do one more. Let's just say t is 81. Okay, again, what you're doing is you're plugging into this solution and just working out the arithmetic. So you'd have 81 minus 80, comma 420 minus 2 times 81, and then comma 81. And that'll give you another solution. Okay, and you'll get an infinite number of basic solutions on this. So you would end up having 1, and if I do 420 minus 2 times 81, that'll give me another possibility. So that's going to give 258, and then you got 81. So what does this mean? That means you can produce one person vote, 258 of the 2, and 81 of the 4. So the idea when you do parameters is you could just make those numbers grow. Eventually you would end up getting into some negative numbers on this again. You know, somewhere in here, there would be another place. So you would end up having a specific number of solutions that you do on that. Okay, so the idea is you have multiple solutions. Does that t thing make any sense yet? It'll get better over time, okay? What'll happen is you're generally always going to end up with the same variable twice. That'll be what your t is. Then plug it in terms of the other two.
So how did you decide that x plus x3 to 2x3 was the same? Wouldn't x1 and x2 be more similar?
How did I decide?
Yeah, like when you're up at the top, of,
Uh-huh.
a little bit more up,
Yep.
You chose negative x3 and 2x3 instead of just the x.
Now, well, okay, remember, what I'm doing is I'm writing, this is what came out on the calculator,
Oh,
right?
'cause you just, oh,
Right, so
You
that's
don't
just
have
x1 minus x3 equals negative 80. Because you have a column for x1, a column for x2, and a column for x3. Right. Yeah, and since the x3s were the same, that's why I let that be
So it
t.
doesn't matter if there's like a 4 and a 2 or like negative and positive as long as you do 2.
Doesn't matter. As long as they have the same variable popping up, then that's how you would know to do that.
Makes sense.
Okay? Any question on that?
Yeah, where'd you get 81 81, t equals 81.
Okay, I chose that. Now the reason I chose that is because of this. Okay, if you look at this solution right here, remember you choose t to get a specific solution. The reason I started at 80 is because 80 minus 80 is 0. If I would have chose t to be 1, I would get 1 minus 80, I'd have negative 79 votes, which is nonsense, right? That's why I started at 80, then I just went up to 81. I would go to 82, 83, and so forth. And I would never expect you to do that because you do this kind of stuff in practice on a spreadsheet and so forth. Eventually, there would be a point in time when that thing would become a negative number. So you wouldn't want to go any further than that. That would be the idea. Okay? That's why I started at 80 and just went up the increment like that. Okay? Any questions?
So that's your solution, and you just stop there.
Well, you can, but you have you have multiple solutions. That's how you write the solution is like this.
No, I'm saying, so I know that there's infinite possibilities from here.
Well, there's not infinite here. There will be a specific number. I'll show you kind of where it stops here in just a second here.
Okay.
So if t is 80, that gives you a specific possibility. There would be 262 person votes, 84 person votes.
I understand.
And then this solution would be one person vote, 258 two person, 81. And you'll start seeing a pattern. That thing's going to go up. The next one's going to go 2. See how this one's going down to?
Right.
You'll see a pattern. So the next one's going to be 2, 2. See how that's going down to?
No, I understand what you're doing. I guess my question is that the answer?
That's the answer right there.
Okay, so
You write it
you're
as
showing
a
us the different
formula,
possibilities.
and then these are how you get specific answers.
I got you.
Now, I'm not going to write all 100 of those, or how many there are,
Yeah.
but you get the formula so that can generate possible answers.
My brain was
Okay.
thinking that you were going to have us answering all those. I got
Yeah, that's the idea. So when we did this on part A, we got one answer.
you. So the parentheses are the answer.
Yes.
Okay, I got you.
Yeah. Or you could write it just in your equations. You could write like this. You could say x1 is this, x2 is this, x3 is t. I usually like you to get to write that as a point, so it's a little bit neater way to write that. Okay, and that's the idea. Okay? All right, and I'm not going to do part C, but you would get a little bit different result. You might think that one you would end up getting no solution on. That's the idea.